presentations will for a better debate. I'm gonna ask all the speakers to stay to 15 to 20 minutes. I will be a little bit more flexible with the keynote presentation. And let me also thank the attendees and the organization for giving us the floor for this very interesting workshop. So with no more delay, please, Pramod, if you want to introduce your work and the keynote speaker, all the audience is really waiting for that.
Yeah, thank you, Mr. Chairman. So I am Pramod Narayan, working as a project director, Dam Rehabilitation and Improvement Project of the government India. So we started this project in the year 2012. It is almost 9 years, which is going to be closed in the coming month, March 2021. Over a period of 9 months, 9 years, we have done a lot of, I think, activities, rehabilitation activities, and dam safety strengthening, project management. So we have the 223 dams in the portfolio, and the rehabilitation cost is around 533 million US dollars. And there are 10 agencies working under this scheme. And these dams are located in 7 states actually of Indian states. So this is the brief of the you can see scheme portfolio. Without wasting much time, let me complete the presentation so we can I can give good question for the discussion. So just give me 10 seconds so we can upload the presentation. This one. So I hope that it is visible now. Mr. Chairman, it is visible to everybody? Yeah. So now I request my colleague, Mr. Saurabh Saran, to go ahead very quickly about the presentation without wasting much time. So Saurabh Saran is my deputy director, working with us in the scheme, and he is one of the pillar of our I think team. Has very good experience and exposure. Saurabh, please go ahead.
Yeah, thank you, sir, and good morning to all of you, and warm welcome to all. As we all know that dams have been unique structures and are strategic for water resource development of across the globe, and they have been providing us with array of services including irrigation, agriculture, water supply, hydroelectric power, ecosystem services, and also recreation services. Also, economic sustainability of all the countries for centuries have depended upon the water resource development, for which dams have played a very pivotal role. So with this slide, I would just wanted to show that there is linkages between the size of the economy and the number of large dams. In this, we can see that China is having the maximum number of large dams and having a huge size of economy, having 23,842 large dams. The second is followed by United States, having 9,261 large dams. And then third comes the India, having 5,745 dams, out of which 5,400 under having constructed and 400 under construction. From the Indians' perspective, if we see the age of the dams, of these 5,700 dams, we can say that more than 25 years of age, about 4,180 dams are having more than 25 years of age, out of which about 1,200 dams are greater than 50 years of age. So in addition to this aging, maintenance, deferred maintenance, and deficiency in the design practices, our dams have been facing multitude of dam safety issues like hydrological safety, structural safety, and operational safety. So keeping in view of this fact, this DRIP program was initiated in the year 2012, as sir already told, in which the portfolio of 223 dams are there, and in this portfolio 89% are older than 25 years and 25% older than 50 years of age. This is one of the example wherein rehabilitation of Krishna Raj Sagar Dam have been undertaken on this ongoing drip. In this, we can see that there are a number of levels of gates at 80 feet level, 103 feet level, 106 feet level, and 114. In this, 136 number of gates are being taken for rehabilitation, and the revision in the design flood has been increased by the 72%. Now coming to the drip project cost. Initially the project cost was when it was started 2100 crore, but with span of time and based on the real assessment of the works which were given during the time of the DSRP inspection, this cost undergone revision. We cannot say it actual variation, but based on the actual assessment of the works, actual requirements of the dam safety requirements, these underwent revision. So we have shown here in a pie chart that how these are varying from state to state. We can see that the variation is ranging from -54% to 69%. So -% is because for the few states or few implementing agencies, the project was closed in June 2020 only. So there have been some amount of savings in that. So that is why this minus percentage is having. UJVNL is having a huge variation of 269%. Why? Because UJVNL joined the scheme in the year 2015, but this project was started in 2012. So this variation is due to the assessment of requirement at a later stage. This preparatory activities is actually the very core activity which is very necessary and mandatory for operationalization of the scheme. So these actually in the ongoing drip, it took initially 3 to 4 years of for initial planning. So these under this drip, there are a few activities like dam safety inspection, that design flood review, then preparation of project screening template. These are the core initial planning which we do, and based on this, the project is operationalized and implemented. So under this project, we have done 260 DSRP inspection of 260 dams, design flood review of 250 dams, and prepared the PSTs for 250 dams. PST is project screening templates. These are some of our observations while carrying out the design flood review of 203 dams. Why 203 dams? Because some of them are saddle dams and have some common reservoir. We have observed that about 33 or 16% dam have no increase in design flood, and about 54% have less than 0 to 50% increase, and 47 dams have 50 to 100% increase. And based on the design flood, we did the flood routing studies also, and we found that more than 51% of the dam have no sufficient freeboard availability. If we get this opportunity to put in the pie chart, this is speaking much more that about 3 dams out of this portfolio, that is 2%, are having in percentage increase of 500% and more. And so this chart is very clear, you can see. To address this in very holistic manner, this design flood review and accordingly the ability of the dam to cater to the dam safety. So we carried out the hydrological safety activities like raising of dam height, parapet wall, additional spillway, desiltation of reservoir, and repair of spillway and conveyance system. So this we did for 171 dams. These are some of the examples like Manimukta Nadi, wherein design flood review. Upon design flood review, there was a revision, and based on that, we planned additional spillway for 4 number of bays and fuse plug of 250 meter long. At Sarthi Dam, which is in Madhya Pradesh, there was a revision of 6.58 times. There we raised the dam height to a certain extent and modified the spillway weir. Now, coming to the stability aspect, we did it for 164 dams, which included backing concrete, embankment and slope protection, dam resectioning, and etc. So these are the examples, like Pichiparai Dam, we did concrete backing for because we found something unsafe from the seismic perspective, and also in Malagata Dam, based on the slope stability analysis, we did the dam resectioning, and we made the downstream slope more flatter. In the seepage control, were done for 71 dams, out of which this joint treatment and grouting and geomembrane is the major activity which we did for addressing the seepage issues. These are some of the examples, like Porthumon Dam in Tamil Nadu and Sarvalar Dam in Tamil Nadu. We did upstream phase raking and pointing in Porthumon Dam, and at Sarvalar Dam we did the geomembrane and also raking and pointing at the joint treatment for addressing the seepage issue. In addition to this physical rehabilitation, we also looked into the improving basic facilities like public facility, providing standby generators, gallery lighting, and surveillance equipment, instrumentation, and all. So this was done for 178 dams. Third-party construction supervision and quality control is considered very important for ensuring high quality of works and also ensuring compliance to the contractual requirements. So under DRIP, we have 3 levels of third-party construction supervision. The first is looked by the contractor who do the execution. Second is looked by the SPMU who look after day-to-day activity, and third is from the central project management unit who are supported by the team of consultants. In this 9 years, we did about 1,092 construction site visits. If you can see in 2017, it was the highest because the project picked up during those years. And we also did some quality control testing, material testing for 605 numbers of samples. Disaster, in respect of, in addition to this physical rehabilitation activity, we are also doing some soft activities like preparation of emergency action plan and operation and maintenance manual. Actually, globally, these 2 protocols are very important, and before the initial filling of reservoir, under this ongoing DRIP, to address these challenges, we supported the states by providing them dam break analysis studies and inundation map. So under this project, 222 number of dam break analysis and inundation maps were prepared, out of which 192 EAPs have already been prepared and 185 has been published. In addition to this, destination of the emergency action plan is also considered as important, for which we are doing stakeholder consultation meeting on regular basis with the states and disaster management authorities and the general public. 85 numbers have been done so far. This operation maintenance, so this constitute 2 things, operation part and maintenance part. Under this DRIP, 203 manuals have already been prepared and 146 have been published. We also provided support to the states for preparing some model documents like operation and maintenance manual for Mathan Dam and for Almaty Dam. Guidelines and manuals are considered as important pillars in the dam safety management. So basically, every states have different dam safety practices and all. So as a central agency or central project management unit, for standardization and uniformity, we prepared these guidelines and manuals. Out of 14, we have already published 11 numbers. Dharma is a dam web-based asset management tool for capturing important dam health information and for long-term sustainability. In this, we have almost captured 5,000 dam data, and about 1,000 users are actively using this, and license have been issued to about 18 states. Conference are also important because for dissemination of knowledge, exchange of knowledge and know-how, and we get opportunity for having exchange of knowledge. So 3 national dam safety conference and 2 international dam safety conference were organized. We can see these, first was organized in Chennai, second in Bangalore, third in Trivandrum, third in Roorkee, fourth in Trivandrum, and fifth one in Bhubaneswar. In this, you can see the size of delegation and a number of papers. So based on this, what we learned on the under this drip that we should utilize for the next phase of drip. During the preparatory stage, we should have proper standardized formats in advance for preliminary proposal at submission. Like we should have this DSRP inspection format, and we should have project screening template format, and we should have a common, already impaneled pool of experts, etc. Second, we learned that we should have advanced planning for high risk rehabilitation activities like desiltation of reservoir or construction of additional spillway. So all those prerequisites like rate analysis, feasibility report should be in place prior to taking those activities. Third is the bankable tender preparation. The tender preparation should be well drafted, well understood, and all technical specification, BOQ, qualification criteria should be understood in time so that in future we can minimize the litigation matters. Fourth is the CS and QA activities, which we are already doing in the drip and also scaling up in the drip phase 2. There's already three level of CS and QA mechanism. Fifth is the monitoring mechanism, and each agency should have right kind of monitoring mechanism so that this activity can be monitored and corrective actions can be taken in timely basis. Sixth is the adequate delegation power. What we observed that there is no adequate delegation of power in the states. So basically, we recommend that there should be adequate delegation. Seventh is the resource identification and assignments. Because in high-end technical activity like dam break analysis, inundation mapping, we are not out there. Dam owners are not having enough capability. So we should have a competent technical group of expertise and training activity for these things. Then contract management experience includes dealing with the contract management. We shall have adequate experience of the contract management. Otherwise, it will invite matters related to undue delay in the technical and financial evaluation of the contract award. We should also have appropriate capacity building, and all the agency must give due weightage to various kind of trainings for their staff and officials. The last is quality human resource in state project management unit, because SPMUs are the single window arrangement for at state level. So they must be having competent officials and having an adequate number of services left before they retire, and they should, so that they can carry out the institutional memory to ensure this implementation of the scheme. So with this, I want to thanks the chair.
Yes, Sarab. I think.
So listening currently.
Okay.
Yes.
I just wanted to mention that the presentation was very comprehensive, and probably when you put all that together from outside your day-by-day activities, you should feel impressed with yourselves. I'm world, as I have had the talk promote many, is looking in your mirror, particularly all the region, but not only. And you are just putting a path forward that the world is be really appreciating. Let me check in the chat if there's a very direct question, which I don't see, but if not, I would like both of you to, or whoever you want to respond, beyond the statistics. What makes you more proud of what you have done till today? If you had to save something of what you have achieved, what is that thing that makes you proud?
Mr. Chair, there are few facts actually that I would like to highlight. Number one, this is one of the unique program globally where these number of agencies are working together. So it's cooperative, you can say, kind of the fertilization system in India. So we are providing the technical support to various our dam owners, and dam owners at the same time they are spending the resources, financial resources. It's a kind of the true federalism that it's happening in this scheme. So one, we are driving the technical side, they are driving on the physical side. Second point is that we have learned a lot of, I think, good things in this scheme. Some of the dam owners are having very limited portfolio, but once they join this scheme, they are having the big portfolio on the cone platform. So they are being given the good exposure to various kind of challenges that the various kind of dams are, I think, experiencing under this scheme. So they have the all kind of, you can say, exposure to the various kind of solutions, various kind of, I think, advancements. So that the second point. Third point is that it's really a challenging, you can say, kind of scheme where if you see the initial phase of the scheme, 3 to 4 years, it took a lot of time in, I think, getting to a desired level. We call it preparatory activities, where we, I think, spend around 4 years. And this is a unique scheme in respect to other infrastructure scheme where you are supposed to carry out certain preparatory activities like the inspection by the dam safety review panel each dam, then their recommendation, then the preparation of the project scheme template, at the same time the general fund review. So without these, I think preparatory activities cannot proceed further. This kind of, I think, arrangement, I think, consumed a lot of resources also in terms of the time and the human resources. So we lagged a lot in the beginning. At that time, our government India and the bank was planning to close this scheme because we are not performing financially also and physically in the initial 4 years. So in the new scheme, we have taken these lessons and we are carrying forward. So up to this stage, I think without assessment of the scheme, we already awarded 30% of the contract, which are in the awarding stage. By you can say plugging all the loopholes, like we have the dam safety review panel, I think, expert at the national level, around 100 experts already empaneled available for the various dam owners. We already standardized the PST, then the region for review formats, and so blah blah. So we took these lessons in the new scheme. And last is that the capacity building basically is a big drive under this scheme. If financially, in terms of finance, it's a very small, I think, peanut for the Indian states. They're spending the project size, I think, in a 1 year time, so many states. But capacity building are really a very good lesson. But another point that we can carry forward that definitely technical, I think, regulations is I think said to be the overarching pillar of the dam safety. So in this scheme, I think we have carried forward some of the new, I think, regulations like the risk assessment, I think, guideline prepared under the scheme now would be implemented in the coming time. Hazard potential classification of dams also very important, and some of the other, I think, standard documents which are available for the global dam owners also and the other dam safety professionals. So these are some of the carrying points actually for the not for the Indian dam owners, but to the whole world. So with these, I think, points back to the chair. Thank you very much.
Thank you. As you know, I've been, and I am, and I consider myself a team. And it's a pleasure when you put all that together and you mention the achievements. It's really and I also feel proud of you. Wanted to know.
Thank you very much, Chair.
Speaker.
Mr. Ignacio, in case we get the time, we have the one small documentary at the end. So if we are getting around 15-20 minutes time, I think we can show to, I think, what we did during the last 9 years. So we have captured majority of the activities. So this is the first time that we'll try to show you because yesterday we completed the documentary. So if time permits at the end of the session, I think see this documentary also. Okay, back to you. Thank you.
Have to make time. It sounds too interesting to miss it.
Correct.
So our next speaker, and I will ask in order to have that extra time for seeing the document, you to fit. If that Sarab made a great job in fitting to the time. So our next is Dinkar Maharan, and under the title Noise Interpretation as a Diagnosis for Gate Deficiencies. Please go ahead. We're looking for Are you there? Let's check. Got my hat connected.
We are not connected now.
You can take the next speaker, Mr. Chair, I think.
But we hear from him. We move to the next speaker. So the next speaker would be then Jagadisan's the Indian extremist geomembrane for Embankment Dams. Please go ahead, and thank you very much.
Good morning, Professor Ignacio. Thank you very much for giving us a slot ahead of the previous speaker. Thanks to the previous speaker. If I have already sent a pre-recorded presentation, I do not know if the organizers can play that. If they are not able to play, I can make a live presentation. So I just request the organizers to check if my pre-recorded presentations can be run.
What do you prefer to do?
Maybe pre-recorded should be fine, and then I can step in at any time.
Okay. Okay. So if the organizers can run the video, we would appreciate.
Anybody from the organizers?
Just in case it doesn't work, if you want to share your PPT on the screen, you have to press the share button and be ready to enter.
So I do not see any response from the organizers, so I think I prefer to take the presentation live.
Let's do that. Go to the share, get the control of the screen. Very good.
Mr. Chair, Jagdisan, I think you may be knowing, they are doing a lot of work in the depth actually. They put one geomembrane in the Fusegate Dam, and they are doing connecting the Upper Bhavani Dam. So they are the very valuable partner in the ongoing depth actually. Back to you, Mr. Jagdisan.
Thank you, sir.
Good. Now you have to make an excellent presentation.
Oh, sure, I'll do my best. Can you see my presentations? Is it visible?
We see your screen. It's about to be loaded.
Okay.
But we see your Windows Explorer, but we don't see the presentation itself.
Okay, I think that's a slight lag.
You can first open the presentation, Jagdisan, and then
Yeah, I
share.
will open. Okay.
Yeah.
That's the other option. You open the PPT and share only that document.
First you unshare the screen, then you open the presentation from the folder, then share. Then only it will work.
Okay.
Okay. Good advice.
Anybody from the Encode? I can see one, I think, fellow who logged in from the Encode side. Good.
Now is it
good.
visible?
Good.
So you can make it the presentation board actually.
Okay. Thanks, Doctor. Thanks, Pramod sir, for giving a good tip. Okay, let me start. Let me introduce. I am Jagdishan Subramanian, and I take care of the Indian operations of the Karpi tech group of Switzerland group, and I report to Mr. Vinayakam Subramanian. He is the director of the Carpi India group. So today's topic of my presentation is Indian experience in flexible geomembranes for water tightness of aging dams. So this is a slide which I've borrowed from DRIP. This is a distribution of the large dams on a decade basis, and you see majority of the dams were constructed beyond 1970s. And if you see the type of dams, majority of the dams are earthen dams and few of them are gravity dams. So when we talk about aging, the one on the left, you can see a typical normal aging process. You see at the age of 5, babies start to crawl, they start to learn to walk, and then 20 to 30, they run, and by the end of 80, they start using walking sticks. This is an acceptable aging process. And if there is something that goes wrong in this aging process, we do consult a doctor. And if there is any kind of problem, we consult a doctor and take treatments. The same is the case with the dams. If we fail to attend to it, it only leads to complications or be non-existent, or it's called as failure of a dam. Lot of aging impacts are there. I only listed few of them. Every dam has its own unique aging process, which are contributed by the type of the dam, the construction methodology, the material and the workmanship of construction, the location of the dam, and the environment surrounding it. Various symptoms of the aging of dams is present. We have only listed few of them. Loss of strength of the mass of the dam, mostly in gravity dams, leakage that is observed on the downstream side, on the toe of the dam, piping in a soil earthen dam, soil erosion, sometimes crack formation in concrete dams, and sometimes swelling of dam due to chemical reactions like alkali aggregate, one of the reactions. So these are some of the pictures of some of the dam failures that we have experienced all over the world. The one on the left top is a dam failure in India, in Gujarat, Mosul Dam in 1979. So let's quickly get into what is a geomembrane. Geomembranes are nothing but a thin flexible material which has a very low permeability. They are highly flexible, they are durable, they provide efficient water tightness, they are able to accommodate settlements, able to elongate with earthquake movements, they can be installed quickly even in underwater. That is a very, very important aspect. It is completely environment friendly, it's easily monitored, there is no maintenance or less maintenance. It increases the longevity of the hydraulic structures, thereby increasing the safety of the entire environment. And finally, when this geomembrane is effectively designed, it is completely cost effective. So there are a lot of geomembranes that are available in the market. We will be seeing the difference between the rigid and the flexible geomembrane. You see on the left is an HDPE membrane, which is very rigid and it is not much suitable for hydraulic applications, whereas on the right is a PVC membrane. You can see the difference in the properties. They exhibit very, very rigid on the left side. On the right, it's very flexible and it's easy to handle. And similarly, you see the stress strain curve, they exhibit a sharp peak for HDPE, whereas in PVC, they undergo large amount of elongation without loss of strength or material damage. Field seaming is very tricky in HDPE, whereas it is very easy for PVC membrane. And if you see HDPE, they have very low puncture resistance and they have burst resistance in the field, whereas PVC membrane, they have very high puncture resistance and burst resistance in the field. These are various parameters which helps us to design why PVC is the most preferred in hydraulic applications. And you can see some of the laboratory pictures. You can see the pictures on the left side, the puncture resistance. And the one at the top is HDPE and the one at the bottom is PVC. You can see how much it can elongate. So the concept of Carpi's geomembrane system is well-proven system in many dams, and Icold Bulletin 135 exclusively talks about geomembrane sealing system for dams. It talks about the design principles and all the review of the experiences that has been combined for many, many years. So since 1960s, this geomembrane has been used in dams and there are no reports of failure. And the efficiency is unquestionable, and Icold acknowledges this efficiency and has gained the appreciation of more 100% of all the designers and the owners of the dams. We will quickly get into the 3 case studies of experience in India. First is the Kadambari Dam. The second is the Spillway Dam. Thanks to DRIP for giving us this first dam project in India. The second DRIP project is Upper Bhavani Dam. So first case study, Kadambari Dam. It's a stone masonry dam. It's owned by Tangetco, and this is the first dam to be rehabilitated with PVC membrane in India. Quickly into the history of Kadambari Dam. It's a stone masonry dam of 67-meter high, 478-meter length, and was completed in the year 1984, and it is a pump storage scheme of 400 megawatt. The problem with this dam is, since its first impoundment, there was a seepage that is experience of 1120 LPM was recorded in the first impoundment. The problem continued, and the seepage inside the gallery kept increase well beyond the permissible limit, and at one point the dam owner could not fill the dam beyond 70% of the FRL, and they were losing huge amount of power generation, and less than 220 megawatt was being generated because they had a fear that the dam could lead to serious consequences if it had to be filled beyond 70% of the FRL level. And you can see the water that is gushing inside the gallery. The client also did not leave it as it. They did try a lot of repair methods that was very much prevalent at that point of time. From 1990s, they tried drilling and grouting. They tried packing at several locations. They again did racking of the joints with cement, and then they filled it with cement mortar. But unfortunately, all these efforts gave them a short-term solution of 2 or 3 years, and the leakage kept on increasing. And in 2003, the leakage touched a point of 38,000 LPM, and that was only through the gallery, and it was at almost 10 meters below the FRL level. It was at this point the client had got in touch with Carpi through some of the international conferences, and then Carpi made a site visit, and then we proposed a solution, and it was immediately accepted by the client. So it all happened in a very short span of 6 months' time, and finally Carpi took over the site in 2004, and we started with the preparatory works. Installation was performed from special traveling platforms, and the geomembrane work started in the middle of January 2005. Let's get into the technical aspects. A geomembrane waterproofing system doesn't end up with a single material geocomposite. There are so many elements that defines the system, and that is why we always call it as a waterproofing system and not a material. So if you talk about the system, there is an anti-puncture layer that is called as a geotextile. There's a drainage layer that is called as a geonet. There's an anchorage element. We call it as a tensioning profile. And finally, the geocomposite. All combined together is called as a system. So a detailed section of the tensioning profile, which is a key element, you can see drawn over here. There are 3 major elements. The one is a lower profile that is fixed to the dam body. And then there is a geomembrane that is rolled from the top till the bottom, and finally the upper profile. This is the key element in fixation of the geomembrane are commonly available in the market, but the key lies in how do you anchor, how do you fix to the dam surface, so that it has to long for the duration of the warranty as well as the life. As I showed in the previous slide, this is the installation of the anchorage profile. It is attached to the dam body, and they can be adjusted to follow the shape of the upstream face, and they're fastened by chemical anchors placed in the stone masonry. And then high compressible, non-compressible geonet was placed along the perimeter seal to collect the rainwater and convey it to the discharge point to the gallery. Then a thick layer of 2000 GSM geotextile is installed on the upstream face. Kadambari being a stone masonry dam, there are stone protrusions of more than 2 inches, and we have to make sure that these stone protrusions do not disturb the geocomposite. So we had to go in for a thick geotextile layer that was installed from the top of the dam till the bottom of the dam. And one more important thing is, way back in 2004 itself, we conceptualized instrumentation that is required, and that was the reason why we installed optical fiber cable behind the geomembrane to monitor the efficiency of the geomembrane even for multiple decades. You can see the geomembrane cables or the OFC cables are installed along the periphery, and the ends of these OFC are taken to the crest and connected to dedicated boxes. And finally, after the installation of the lower profile, the geotextile, then comes the main element, that is the PVC geocomposite. The composite that we use is a 2.5 mm PVC heat coupled with a 500 GSM geotextile. You can see the gray one that has been installed from the top of the dam till the bottom. And then the next tensioning profile, that is the top profile. So once the lower profile is fixed, the geocomposite is rolled, and finally the top profile comes, and after welding all the composite panels together, the external profiles are placed over the geocomposites, and they are connected to the lower profiles. The tightening should be done in such a way that there is no excess tight, so that it ties the membrane. At the same time, it should not be too loose, so that it does not form any wrinkles. That is where experience of the key technicians comes into picture. And finally, after all these installation is completed, we terminated all these membranes at the bottom using a watertight perimeter seal. And what is watertight perimeter seal is covered with using resins, gaskets, and bedding mortars. And this is the key element, that is how do we discharge the water behind the membrane. As I said earlier, the biggest plus of this system is this is the only waterproofing system which has a drainage layer encomposed, meaning if there is any kind of water entry inside the dam body, we ensure that if the water is properly conveyed into the gallery and it does not allow entry into the downstream side or the body of the dam. So you can see these are the drainage discharge pipes that are installed from the upstream of the dam to the gallery. And finally, the entire installation covering more than 17,000 square meter, including the monitoring system, was completed in 3 months, which was 6 weeks ahead of the schedule. And in fact, for the first time in the history of Tangentco, the Tangentco had paid a compensation of 51,000 euro in 2003 for early completion and for handing over the dam much ahead of the time, so that they can begin the generation ahead. Finally, after all the installation, the entire dam leakage was brought down to 80 liters per minute, which is close to 99.8% reduction in the leakage. You can see this is how the dam looks like before geomembrane and after geomembrane. You can see a completely dry gallery. And for the success of the project, Karpi was awarded with India Power Awards in the year 2008. And the award was received by our chairman, Mr. Alberto M. Scuro. So this is a photograph of Kadambari Dam taken in 2018, which is almost 13 years after the installation. And till now, the leakage is around 100 liters, which is marginally more than what we left, and which is still well below the permissible limit. Let's quickly get into the next case study, that is the first dam project of DRIP Servala Dam. This is a stone masonry dam located in Tirunelveli district in Tamil Nadu. The dam also belongs to Tangentco, and there is a multi-purpose functionality of this dam. Majority of the dam's purpose is for irrigation, and the power house is run based on the water needs on the downstream side. So as I said, the major purpose is drinking water and power generation only for a seasonal duration. And this is was also constructed in the year 1986. It's a 57-meter high dam and 465-meter long, and it is operated and maintained by Tangentco. I have a video to run. I'm not sure if it runs over here. Okay, let me go to the video and then I'll get back again.
Okay, right.
Can you see the video running?
No. No, we still see a gray screen. It looks like maybe now. No.
Okay, just a minute.
Jagdishan, it's not running. You can, I think, tell salient, I think, facts to the audience.
Okay.
You're wasting your time.
Okay, I'll go to the video at the end of the session. Maybe I'll see by then I'll be able to locate the problem. Can you see the screen now again?
Yeah.
Yes, we can. I take the opportunity.
Do you see,
if you could finish in about 5 minutes, that would be wonderful.
Yes, I'm coming to the end of the session. Can you see this slide on problems encountered?
We see
very
the slide. Yes.
Yeah,
very
okay.
well.
So you can see this is the picture of the Servala Dam downstream side. Heavy seepage on the downstream side on the left flank of the dam. before we took up the job in 2016. And this is the categorization of the dam. The dam is divided into left spillway and the right flank. Majority of the dams were observed on the priority on the left spillway and the power blocks. Most of the leakage were from the left and the spillway sections. And when you talk about the challenges that we faced during this execution, the dam is located on a perennial river, and which was a very, very challenging job, and we had to do a lot of desilting and dewatering works. And unfortunately, this dam region is located in a locality wherein it rains for almost 11 months out of 12 months. So you can just imagine how difficult it was to do the desilting works and the dewatering works. The reason for doing a desilting and dewatering works is we need to go and install the membrane as deep as possible, that is close to the foundation. And another biggest challenge was there was non-availability of as-built drawing, and unfortunately many dam owners are not having this as-built drawing, so there are a lot of surprises when we started excavating. And there was a lot of delay in dam depletion, and there are several lot of structures which was not in the drawing earlier. And this dam is located in a windy location per hour to 75 km was blowing, and you can imagine the risk that was involved when we are installing the membrane. So you can see these are the platforms that were installed that are used. I just want to make a comparison between Kadambari and Servolar. Kadambari was the first project for Karpi, so we did not take any risk. So we imported all the materials, and now in Servolar we have become completely indigenized, and all the platforms are locally made. And we can see the Geomembrane installation started in Servolar, fixation of the top seal, the fixation of the lower tensioning profiles. They have been fixed at regular intervals, and holes are drilled to a depth of 6 to 8 inches using chemical anchors, and they are put in place. Then a geotextile. This is also stone masonry, and a lot of protrusions were observed, and so we had to use a geotextile of 2000 GSM. And then the geocomposite, which is 2.5 mm GSM, was installed from the top of the dam. You can see on the left, the geocomposite is getting rolled from the top, and we can see the installers in the platform. Adjacent sheets of geocomposites, which are of 2.1 meter width, are being rolled, and then the connections are connected by hot air seaming. Once all these rolls are unrolled, there is a low upper profile. The upper profile, we don't leave any stainless steel exposed. We cover even the upper profile with a cover strip. So from the outside world, it looks like a pure gray material that is lying. And finally, a quality check is being performed. You can see a seam check, torque check, a welding check being carried out. And finally, after the installation of the system, you can see the difference. Immediately within one season, you can see a completely wet downstream has become a completely dry downstream side. You can see the drop in the leakage from where it was, though the leakage that is measured in the gallery was around 800, the downstream leakage was never measured, and it was close to 4,000 to 5,000 liters, and now there is hardly any leakage. And let's quickly get in this another 2 minutes. I think I should be able to wind up the presentation. The next job is right now, which is in progress. We have almost completed 60% of the job, and due to COVID, the project had to be extended to this season. This is a very huge dam, 82 meter high and 426 meter long, and this is the second dam project under drip. You can see this leakage is almost on par with Kadambari. You can see the leakage when was measured was around 8,000 liters at close to 9 meter below FRL level. And as per calculation, if it fills to the top level, the leakage would be easily more than 18,000 liters per minute. And unfortunately, this dam was declared a distress dam way back in 2005, but the client could not take a decision on a conclusive repair work, and finally DRIP came to the help of Tangitco. And you can see the leakage inside the gallery as well as on the downstream side. These are very, I'm just showing few of the photographs. You can see extreme leakage. And here the only difference between these previous projects and here is, since the head of the water is high, we had to use a thicker geocomposite, which is a 3 mm geocomposite. One more additional element which we have included here is optical fiber cable. Like we did in Kadambari Dam, optical fiber cable was installed all along the periphery of the dam behind the geocomposite. This is to ensure how the performance of the geomembrane is over a period of decades. Since we give a life of 70 years, we need to ensure the performance of the geocomposite still remains. You can see one more important thing which we did is we made sure a parallel quality check is done by the clients. And you can see the image on the right is done by the client. The client's assistant engineer has been asked to get into the platforms where they were very reluctant, but we forced them to get into it, and then we made sure that they are doing the quality check along with it. And we have the quality documents signed by them as well. So this is the protocols that CAPI follows in all our projects. And we can see this is the photograph of Upper Bhavani Dam after the completion of the 2 phases. The 3rd phase is in progress, and hopefully by June we should be able to complete the entire work. So finally, a conclusion table. You can see the leakage before geomembrane and leakage after geomembrane. You can see there is almost 99.8% reduction, and this is what CARPI sells, and we don't sell a product. We sell a system. At the end of the day, we are looking at giving us solutions to the client which are completely satisfied, and they should never come back to us for the next 20 to 30 years. This is our expectation. And thank you very much, Chairman, and Dr. Pramod sir, for giving us this wonderful opportunity. And I thank the audience for patiently listening to this presentation. And since I'm sorry I could not play the video, we will try to see if we have time, we can play at the end of the sessions, if the chairman allows it.
Very good.
Thank you, sir.
I was also checking in the chat, but I don't see any direct question. As we are willing maybe to see by the end of the session, I'm going to skip the questions. So I'm not going to make any particular question. And we are moving to the next speaker. Thank you for your excellent presentation.
Thank you.
So
thank you.
This I would call Mr. Hassan Kokhan. Are you connected, Hassan?
Yes. Yes.
Yes. The title is Grading of Pipe Dam Spillway the Fusegate System. And we are very much looking forward to hearing from you. Remember to try to 15 minutes than 20 minutes. Thank you very much.
Sure. Can you see the screen?
Yes, very well. Well, we see is that PowerPoint, when it duplicate it shows you also the PPT ahead. That's typically because PowerPoint duplicates the screen or something like that.
No, actually, I have 2 screens, so one of them is probably.
That's why. If you can switch off one screen, because I think automatically when there's 2 screens, PowerPoint does things like this. Otherwise, we can follow.
Yeah. Okay.
Yes, proceed. I mean, we can follow it. It's just that you will not surprise us with the next slide.
Okay. All right. Well, sorry about that. Yes. Well, I'd like to thank you for giving me the opportunity. My name is Hassan Kocahan. I'm the manager of the US subsidiary of HydroPlus, which is the developer of the Fusegate system. The Fusegate system is a non-mechanical spillway control system for increasing spillway discharge capacity and also increasing reservoir storage capacity. And today I'd like to give you a presentation about one of our case study projects, which is called Pikes Creek Dam. And here we go. There's a freeze. Okay. So Pikes Creek Dam was constructed in 1908 and it was completed in 1911. And it's owned and operated by Pennsylvania American Water. It's used for water supply, and it's located about 8 kilometers northwest of the city of Wilkes-Barre in the US state of Pennsylvania. The dam is composed of a homogeneous embankment, which is 657 meters long and about 20 meters tall. And there is a reinforced concrete core wall in the middle. And here we see a satellite photo of the dam. You can see the long dam embankment, and then on the left side of the the photo, we have the main spillway. It's not easy to pick. And then on the right side, we have the auxiliary spillway. And this dam stores about 11 billion liters of water. And here we can see some additional photos. The dam has an upstream and downstream slopes of 2 to 1. And here are some information about the other structures of the dam. We have the outlet works, which is composed of 3 pipes having a diameter of 76.2 centimeters. And it also includes downstream gate valves. The principal spillway is a concrete OG free overflow spillway. And the auxiliary spillway is, you can see in the middle of the photo, it's also a free overflow spillway. There is an OG press, and there was steel flashboards, which open manually when there is a major flood. And the capacity of both of the dams were 23% of the PMF. And the problem with the dam was this dam is located in an area where there are a lot of people living downstream, and failure of this dam would cause significant economical damages and also loss of life. So after evaluation of the hydrology, it was decided that the design flood requirement had to be full PMF. So we needed to increase the capacity of the spillways. And while doing that, we had some requirements. We couldn't, for example, increase the dam embankment. We couldn't increase the maximum water level. We couldn't increase the outflows up to 100-year floods because there are many structures at the downstream of the dam. Since this is the water supply dam, we can see the office buildings as well as the water treatment plants at the downstream. We also have a bridge that is connected to, that is under the highway that is running. So we had to protect all these structures while rehabilitating this dam in order to meet the new PMF requirement. So we see all these structures. So for the rehabilitation works, we couldn't do any widening on the main spillway because it was difficult to do any modifications with the topography, and also it wasn't possible to make major changes at the road at the downstream as well as the bridge. And then but some repairs had to be done on this project on the spillway because there were a lot of concrete damages at the base, at the chute, which had to be repaired. And also during a high flow, the water was overspilling from the left side of the wall, so which had to be raised. So at the end, the majority of the rehabilitation was focusing on the auxiliary spillway. We had to increase the capacity from 392 CMS to about 1100 CMS. So in order to do the rehabilitation, there were several alternatives developed. To start with, it wasn't possible to consider flashboards and earthen fuse plugs, which are not allowed in the state of Pennsylvania by the Dam Safety Regulatory Agency because of reliability issues. And also using mechanical gates were not encouraged because, as you know, it requires human intervention. There is mechanical and electrical systems involved, which might fail during very large floods. And also there is also a potential for misoperation during very large floods. So there were 3 alternatives developed for increasing the capacity of the auxiliary spillway. The first one was using a large labyrinth, fixed labyrinth structure. Just to remind you, the existing spillway was a 76-meter wide spillway. So in this alternative, this spillway was going to be increased to 145 meters. And then with the total cycle length, we would create a weir length of 710 meters. And this would be the spillway that will be operated during a large flood. So this alternative had a lot of disadvantages. But first of all, you don't want to mess with the existing dam embankment. It's not an ideal situation to try to take some space from there, which also causes the project to be very expensive. And then for the routing of the flood, this alternative also created a lot of complex hydraulic conditions. So this alternative was eliminated. The second alternative was keeping the same footprint of the spillway and constructing another fixed labyrinth weir, which would pass about 50% of the PMF. And then the remaining 50% of the PMF would be through the dam embankment by creating an RCC or similar system for doing an overtopping protection. So reminding you about the dam embankment, it's a 640 meters long structure. So basically you're trying to create a spillway throughout this entire dam embankment. So the flood will be not only discharged through the spillway, but also through the entire dam embankment. And here's a photo of some of the alternatives for creating this overtopping protection. One of the most common ones is roller compacted concrete overtopping protection. It's also possible to use articulating concrete blocks, for this purpose. So this alternative was also eliminated because of all the costly and most importantly hydraulic constraints, because you couldn't discharge all that water, which would inundate the downstream roads. So the third alternative was again using the same footprint of the spillway and install fuse gates. And there will be no other modifications required on the dam embankment or any other structures. So by the fuse gate alternative, we were able to pass all the PMF and through the both spillways, and then we were able to protect all the downstream structures, the water treatment plant, as well as the road and the bridge. And the normal reservoir level will be maintained. And also, since we are not changing the maximum water level, we wouldn't need to do any protections on the dam embankment. Here, the fuse gates will start opening for a flood that is so rare that it would correspond to 23% of the PMF. So basically the design flood of the previous condition before rehabilitation. So for those of you who are not familiar with the Fusegate system, here is some information. Fuse gates are freestanding blocks made of steel or concrete set on a spillway seal, and they form a watertight barrier. So we put these gates side by side on a broad crested weir, and then put EPDM seals in between, and also between the spillway seal and the fuse gates in order to create a watertight barrier. So this is the cross section of the fuse gate. Fuse gates is composed of a main structure. There is an inlet valve, and there is a chamber which is connected to this inlet valve. There is a small drain hole at the downstream of this chamber in order to discharge any leakage inside this chamber. And this is the yellow section is our spillway seal, and the spillway seal is also equipped with a toy abutment, which holds the fuse gates in place so that they don't slide when there is water upstream. So this is the normal operation. The water will be stored up to the crest level of the gates, and most of the floods will be discharged over the crest of the fuse gates as if they would discharge over a fixed labyrinth weir, except that these gates are sitting by gravity. They are not fixed to the spillway seal. When there is an exceptional flood, which we can predict what kind of flood that is, because each inlet valve of the fuse gates are set at a different elevation, which is designed in the beginning. And when the water level reaches this elevation, it will start filling the inlet well, and it will start fill up the chamber. And at this point, the discharge capacity of the drain hole is not able to withstand all the to cope with all the incoming flows. So there will be an uplift pressure generated inside the chamber, and the fuse gate will start rotating about this toe abutment, and it will tumble down and be washed away from the spillway. So this is depending on the magnitude of the flood, one or more fuse gates will open in order to pass that flood. And once the flood is gone, the gates will be replaced. Of course, this is a non-mechanical control system, and what makes a fuse gate system feasible is this tipping probability has to be so low that it will barely happen during the life of the dam. Those are the types of floods, magnitudes of floods we select for the fuse gates. So for the Pikes Creek Dam, the fuse gates will be installed on the existing Speedway Seal, which I mentioned. It's about 76 meters wide. So there will be 18 fuse gates. They're about 2.84 meters high and 4.19 meters wide. Each fuse gate weighs about 36 tons, so it was possible to make them precast concrete. Since we have 18 fuse gates, we didn't need to put one inlet valve for each fuse gate. In this project, we had each tipping involves more than one fuse gate. So in order to reduce the number of inlet valves and make the project more cost effective, we used deflectors, which was connecting the chamber of the adjacent fuse gate to the master fuse gate, to the main fuse gate with the inlet valve. So when this fuse gate tips, when it opens, it just basically opens this deflector, which is basically a lid to an opening pipe to the chamber of the adjacent fuse gate. So the water will fill the chamber of the next fuse gate up, and in this group, the fuse gate, both fuse gates will be tipped. Here are some photos for the construction and manufacturing of the fuse gates. Here we have constructed a custom formwork for the construction of the fuse gates. And here, all the rebars were assembled as a cage outside, and then they were installed inside the formwork, steel formwork, and the fuse gates were cast in as one lift, in one lift without any construction joints. And then all the steel components were stainless steel, and these were from the fabrication yard. And we also performed dye penetration test at the end of the manufacturing. Once the fuse gates were cast, we did a jacking operation in order to weigh the fuse gates and verify the ballast requirements for each gate. Now, we put concrete ballast blocks inside each fuse gate because since they tip for a different reservoir elevation, they have to have a different weight in order to withstand that water elevation. So by weighing those, we identified the ballast requirement for each fuse gate. So once all the fuse gates are manufactured and our Speedway Seal is ready, the gates were delivered to site by trucks. And before they were installed, we have cleaned up the Speedway Seal and marked the exact location of all the fuse gates on the Speedway Seal, and then they were installed on their final location directly by a mobile crane. And once they were installed, we just bolted all the inlet valves. And then here you can see the ballast blocks for each fuse gate. As you can see, they have different thicknesses because depending on when the fuse gates tip, they have to have different weights in order to withstand that exact reservoir elevation, to withstand that hydrostatic force. And then here we installed the rubber EPDM seals in order to create the water tightness. And in order to fix those, we use also stainless steel flanges in order to bolt them onto the fuse gates. When a fuse gate tips, we arrange the rubber sealing system in such a way that the fuse gate that is tipping before the adjacent one will be free from the rubber seal, so that it's not hampering the tipping process. And then here we can see the horizontal seals installation as well as the installation of the deflectors. And finally, this is the completed project. The Fusegate system helped the owner save a lot of money because these are non-mechanical Speedway gates. And as you can see, there are no moving parts that might wear or tear. These are just reinforced concrete components with stainless steel pieces. They have very long longevity without any requirement for maintenance. And most importantly, these are very reliable during major floods because you don't need any human intervention requirement, and you don't need any source of power to operate them. And these are also very fast to install. For example, for a project this scale, the total installation was about 1 week after all the fuse gates were manufactured. And the advantage of the system is also when the Spillway Seal is modified, all the manufacturing fabrication can be performed at the same time. And this system is also very robust against any vandalism. And also there is no source of pollution that might contaminate the water, especially in a project like this, which is used for drinking water supply. And also, just to mention, we have 13 completed projects in the state of Gujarat in India. So that's all for the presentation. I thank you for your attention.
Thank you, Mr. Hassan, for making a very good presentation. So in case there's any, you can say, questions, anybody would like to, I think, ask you anything, floor is open. Mr. Chair has gone to make a one presentation in the panel session actually. Dr. Ignacio already, I think, busy for 20-25 minutes. So he has handed over the session to me. So we would like to, I think, listen anyone of us would like to ask anything from Mr. Hassan. So excellent presentation actually, since I am dealing with the drip actually for the last 5 years, and we are exploring so many, I think, innovative, I think, solutions to our these dam rehabilitation problems. So Fusegate, I think, one of the, I think, very good, I think, solution as compared to the some conventional kind of things that we are providing in our dams. Definitely would like to, I think, invite you in some of the, I think, our official meetings to make a presentation in the coming time. And if possible, if possible, then we'll provide such kind of solution in some of our dams also, because we are starting the new scheme. So from my side, I think we are exploring the innovative solutions for rehabilitation of the dams. So
Sure. We'll be at your disposal if there's any way we can help you.
Correct. So anyone on our side actually would like to ask you anything?
Mr. Pramod, yes, I would like to ask a question to Mr. Hassan.
Yes.
Yes, thank you for the interesting presentation. My question is about the maintenance, especially regarding these inlet wells. I think it's necessary to check that they stay without any obstructions over time.
Yes, so let me give you some information about the general maintenance requirements. So every project, we prepare a customized O&M manual, operation and maintenance manual. So we have, for example, annual checks, which can be done just looking from a distance to the project, just to make sure there is no blockage in the inlet wells, for example, because of bird nesting. We have trash racks in the opening, so there won't be anything that will, make like some big pieces that might go into these inlet wells. Whatever they can go in there, they can be discharged, they can be flushed through the little drain holes. But of course, they have to be checked and cleaned once a year. If there is no blockage, you can look at it. And then we have 10-year inspections where we like to, in the manual we give all the procedure. You can put a cable camera inside the inlet wells and check if there are any blockages inside. And also the EPDM rubbers, in the past, before this EPDM technology was improved, neoprene was used, which had a lifetime of roughly about 10 years. But interestingly, with this EPDM technology, we have been dealing with different suppliers in the United States and Canada. These EPDM seals can last 40 to 60 years without having to be replaced. If they are in ideal conditions, which is if they are, for example, under a bridge pier, they can also be used, under bridge piers. If you don't have direct sunlight, they can last as long as 50 to 60 years, the manufacturers told us. So in our operation and maintenance manual, for example, every 10 to 20 years, if everything looks good, there is no replacement to be done for the EPDM seals. Whenever, in the long run, if they look dry or deformed, then they can be replaced, which are quite inexpensive. They are about $100 per linear meter of the seals. So those are the general, simple O&M requirements that can be done in-house by the dam owner in a very cheap way.
Okay, thank you.
In addition to point raised by the Mr. Jagan, can you throw some light on the cost aspect? Actually, conventional gate, if I'm putting with the radial gates with the hosting and the trestle platform, and I'm putting this one, what kind of saving is there in the cost?
Well, there are, every project is different. The bigger the spillway gets, the more economical the Fusegate system will be. The most important reminder is it's not only the initial installation cost that you have to compare, when you're comparing the Fusegates with a mechanical gate, you need to look at the life cycle cost. Let me give you an example. You're familiar with the inflatable dams or Obermeyer systems. They last, maximum. Well, in their brochures, they say they can last 15 to 20 years, but ideally they need to be replaced 10 years. The Fusegates with the reinforced concrete, a reinforced concrete structure, we use very high strength concrete. They can last a long time, maybe 80 to 100 years, and the initial installation cost would be less than half for example, mechanical gates. But most importantly, you don't have to spend any more money over the life cycle cost for maintenance or operation. For example, with the mechanical gates, you need to, allocate human resources. You need to do a lot of maintenance, and also there will be electricity consumption. With the Fusegates, you don't have to worry about any of those long-term costs. So it's important to make a comparison with the life cycle cost of the gate system rather than just the initial cost. With the rubber dam alternative, you will have to replace maybe 5 times, 6 times the entire system before you need to do any significant expenses for the Fusegates.
Yeah, at the same time, Mr. Hassan, if you can throw some light, we are not losing some kind of flexibility in dealing with the kind of disaster. For example, if we are having mechanical gates with the manual operation or automatic operation, we can, I think, open the gates in advance. As some big flood is, I think, anticipated, there's some big forecasting. Then we can, I think, empty our dam. But at the same time, these kind of gates are requiring some kind of, I think, water levels to I think, get operated.
Well, here is the thing. The Fusegate system is a passive system. We don't. Think of it like it's a fixed labyrinth weir. So you are not going to be able to do any operation of the reservoir. But for example, if there is a spillway with a main, with like 2 spillways in a dam, with the main spillway having gates, radial gates, or any other mechanical gates, you can install the Fusegates on the auxiliary spillway. So you can only, you can operate the main spillway in order to control your reservoir. But if there is only 1 spillway in your dam and you need to have only a minimal operation, maybe in that case, we have projects where you can put Fusegates on the 90% of the span of the spillway, and then just a small section with any mechanical gate to your liking. So that way you can operate your reservoir level as needed through this part, and then the rest would be just a passive spillway system. And we do this optimization based on the flood routing of the spillway. We do a custom study for each project in order to determine the project requirements. so that you can have one gate or two gates, mechanical gates. You know, we can optimize that based on your operation requirements.
Yeah, thank you very much. I think you are working some dams in India, Gujarat. You touched upon at the end of the.
Well, we have finished our projects right now. We don't have any active projects going on in India.
Okay, okay. Thank you very much. Thank you very much for making a nice presentation. Now we can invite the next speaker from Wallingford, UK, Mohammad Hassan. I think, okay. Mohammad Hassan, are you available right now?
Yes, good morning, Mr. Chairman. Good morning, everyone. Yes, I'm there. This presentation is actually done by one of my colleagues, Mark Morris, and we uploaded a pre-recorded video of the presentation. Can the organizers play this pre-recorded video? And I'm here to answer any questions if there are questions.
So let me inquire from our Icold symposium organizer. Anybody from the Icold? Can you please help us?
Yes, sir. I play.
So please, can you play the presentation of Mr. Hassan? Thank you.
Can you unmute, because it seems to be muted?
I think voice is not coming. Have you unmuted the voice? My Icold fellow? Your mic is mute actually. Can you unmute your mic?
Hello, I'm Mark Morris, and I'm pleased to have this opportunity to present this paper on Embryo Web, which was co-authored by my colleagues Mohammed Hassan and Craig Goff back at HR Wallingford Limited in the UK. Quick overview of what I'm going to cover. Firstly, why develop an online breach model? Secondly, an introduction to the Embryo breach model. And then an introduction to the online versions of Embryo, which is Embryo Lite and Embryo Pro. Finally, I have a few slides covering future developments and related research initiatives. So why develop an online breach model? Fundamentally, we wanted to encourage users to play with a breach model, to have access to a breach model, rather than using simplified discharge equations. By having access to and being able to play with a breach model easily, it's users are better able to understand the sensitivity and uncertainties involving different parameters in the breach prediction process. Improved understanding of processes and their implications means that there's a better understanding of when you can use breach models and different breach simulation processes for different end-use applications. Ultimately, this should improve the accuracy of breach predictions used by different end users. So first of all, looking at physical processes and understanding what happens when breach occurs. Just wanted to point out that there are a number of macro processes that take place, such as head cut, shown in the top left here, and surface erosion over on the right-hand side here, as well as internal erosion, seepage flows, and so on. And depending upon the presence of these processes, the breach hydrograph that occurs and the rate of breach formation is affected. This can significantly change the magnitude of the breach flood, the timing of the breach flood, and so on. So it's important to understand when and how these processes occur. Understanding the sensitivity of breach prediction to different parameters, such as your dam or levee geometry, or your soil erodibility, is equally important. The plot on the right here shows different hydrographs that could occur for a simple homogeneous structure with different types of soil. And finally, thinking about uncertainty and understanding that it's present, and the magnitude of uncertainty in relation to the end application is particularly important. Some end users, it will not be so significant, but for others, it could be very significant. So users should understand why they're doing the prediction and how their data will be subsequently used. Let's move on to the Embryo model itself. Embryo evolved from the HR breach model, which was first developed in the late 1990s by Mohammed Hassan. It aims to combine the different breaching processes within one model. So it combines the capability to predict head cut erosion using the wind down procedure, surface erosion or internal erosion. It also includes for the effects of surface layers such as grass cover, rock and block failure, and also for the effects of cores within structures and zone structures where you've got multiple types of soil and different layers affecting the way in which the breach develops. The model integrates analysis of hydraulics and erosion and structure response. It aims for a similar level of complexity in its analysis of these different aspects to give you the overall breach prediction. So the Embryo model is not calibrated to specific data, so it does not reproduce a specific example or case study, but it is validated against a wide range of data so that its performance falls within a range for a variety of different structure types and scenarios. So the Embryo breach modeling process is, as shown in the diagram on the right-hand side here, it considers sections through the dam or levee. So it's not a single point calculation. It calculates the hydraulics and the erosion at each of those sections progressively through the structure and allows for free progression of the breach in that way. The progression of the breach erosion process is not predefined or constrained. It's based purely on the hydraulics and the erosion at each of those sections. So the calculation process, after defining the embankment geometry and the section spacing, is first to identify a critical flow section. That's a point across the dam or levee that is controlling the flow over the structure. It then calculates the discharge and flow profile back through all sections, or across all sections. And then section by section, it calculates the sediment erosion and calculates new profiles at each of those sections. In doing that process, it also looks at side slope stability for each of the sections, allowing for block failure as the flow erodes and undercuts the side of the breach. This allows us to predict breach growth as shown by the diagram on the right of the screen. This particular example shows a levee with two layers, and the top example shows a more erodible top layer, hence the top layer disappears faster than the bottom layer. And you have quite a flat structure. The bottom example shows the case where the lower section of the embankment is more erodible, and you have a much steeper face as the flow cuts back through that levee. This highlights the importance of looking at zone structures and soil erodibility. The top example cuts through to the reservoir very quickly and releases water much more rapidly than the bottom example. I mentioned that the model checks section by section and looks at side slope stability and block failure. So it does this by considering the erosion around the section through the breach, and then it considers the block instability at each time step for rotational block failure or shear slip failure. If you have a core to your dam or levee, it does this, it looks at the stability of this in a similar way. And as the supporting fill material is eroded and the core becomes more exposed, it checks to see when failure may occur with that core. So how does Embryo Web different from Embryo? It's not different. It's simply an online version of the Embryo model. Because it's an online version, the simulation takes place on a server based at HR Wallingford in the UK, so no software download is required. To gain access, you need to register, and then there are two versions that you can use. There is Embryo Lite, which has pre-access free version, or there's Embryo Pro, which has more functionality that has paid for access. So if you wish to access those models, the web address is shown there, and you have a choice of these two options. I've got a slide later on which goes into more detail about the differences between Embryo Pro and Embryo Lite, so we'll come back to that. What do you find when you log in? First of all, this is the Embryo Pro homepage. You'll see that you have various data entry screens, or on the far right hand side, the settings screen. If you go to the settings screen, this allows you to load previous files or to save setup files so that you don't have to re-enter the data every time. If we then work through data sheet by data sheet, under the failure sheet, you get to choose whether it's overtopping or head cut or piping. You can define your structure type as a homogeneous or a layered or a chord structure with spillways and outlets, with downstream face protection and so on. In terms of the outer geometry, you can define the crest length and width, the slope angle, foundation level, and so on. Next screen is your material properties. This is where you're defining the different soil properties of the soil that your dam or levee is built from. And then you can define your breach parameters, any constraints on breach depth and breach width, along with the erosion relationship that you wish to use. It's worth noting that all of these data fields have an information hover over button, which explains what the parameter is, why it's required, and where available recommendations on values to use. You define your upstream reservoir, your upstream nature of the boundary condition, your downstream boundary condition, and you can upload, if this is a stage volume relationship, you can upload that definition using a CSV file. You then define your computation parameters, your start time, simulation time, time step, and so on, along with more detailed run parameters if you wish. When you run the model, you simply define your model run, and you'll get a screen such as this, which is saying that either the model run is running, or that the run has finished successfully, or if there's any problems, equally those will be detailed. You can then look at a summary of the run results. You can look at a plot of the flow results. You can look at a plot of the breach width and depth evolution. You can print your results. You can save your results to a zip file. So I mentioned earlier that there's two versions, Embryo Pro and Embryo Lite. The difference between those two versions. So Embryo Pro obviously has all functionality. Embryo Lite does not allow you to do layered or zone models, or models with a core or a dam with spillway and outlets. It also doesn't include the functionality for multiple methods of critical section analysis, various calculation options, drowning of the breach process, choice of multiple erosion equations, probabilistic representation of soils, Monte Carlo functionality, and detailed output files. Naturally, all of those are included within Pro. So the purpose of Embryo Lite is intended to allow users to get a feel for possible behavior by doing some quick, simple runs as you would using a big discharge equation, but this time using a predictive breach model. Okay, so that was a quick overview of Embryo, Embryo Lite, and Embryo Pro. And to wrap up, I've got some slides on future developments and research related to the model. So fundamentally, we've continued over the last 2 decades to implement various research projects to improve our understanding of the breaching processes, and that knowledge then feeds into the models. So we will continue to update the functionality of Embryo as the knowledge continues to evolve and advance. In the near future, we expect to update the user interface by simplifying it. And we also expect to include erosion below foundation level as an added functionality. In the long term, we intend to add guidance on soil erodibility and updated guidance on transitions between head cuff and surface erosion and when to use each of these different processes. So then two final projects to wrap up. One is the Overcome project. This is the creation of a field test facility, large-scale breach tests in Spain. The project has a combination of laboratory tests, field tests, and numerical analysis. The laboratory tests are undertaken at UPM in Madrid to a scale of 1 meter, and the field test facility allows tests to a scale of 2.5 meter full section profiles. The objective here is to investigate both macro erosion processes and micro erosion processes. So by macro, we mean when does head cut occur, when does surface erosion occur, when does slumping occur, and micro is soil erodibility and the different cases for how soil erodibility changes with soil state. So the field test facility is about an hour outside of Zaragoza in Spain. It's based in an irrigation area using flow from an irrigation canal shown here at the base of the picture. And this facility will allow us to test sections of about 10 meters width, 2.5 meters height. The final project I want to mention is EDF funded work looking at internal erosion initiated breach models. We're comparing in much the same way as we did for the Dam Safety Interest Group breach modeling project. We're comparing the performance of different models to predict breach that's initiated through internal erosion. Models that are being compared include Ariba, DL Breach, Embryo, Rupro, Windam, Ava Breach, with multiple modelers from different organizations around the world. We have a 2-year program here comparing the performance of these different models against each other, both blind and aware modeling to help distinguish between model and modeler effects. So thank you for the time. That was a very quick overview of our breach work. If you have any other questions, please do not hesitate to contact myself, Mark Morris, or my colleague, Mohammed Hassan. Thank you.
Thank you, Icold fellow, for putting the presentation. If anyone, I think, wish to ask any question for Mr. Hassan, floor is open for a few minutes. Still, I think chair fellow is not back from the panel session. So, Mr. Hassan, can we, I think, discuss some points actually, since I didn't see any question from the participants. So, can you throw some light on these breach models basically? Is it a one-dimensional, two-dimensional, three-dimensional modeling capability does it have, or it's only one-dimensional? Our fellow from the Wallingford. Hello. Hello. So I think our guest from the Wallingford, I think, is disconnected right now. Now we can proceed our next speaker.
Excuse me, sir. This speaker video is available. The video is play. Yeah, wait for speakers join.
I think if speaker is available, then speaker can, I think, present the case very well. Or if you wish, then we can play your presentation also. It's up to you. So, Mr. Malayala, Viraj Malayala, what you would like? Would you like that we should, I think, play your pre-recorded presentation, or you would speak live? Hello. Yeah. So
back.
to take you back to, I think, session. So please, I'm handing over the chair to our chair fellow, Dr. Ignacio. So now we are, I think, at the serial number 6 actually. So our presenter is live. So our fellow from the AECOM would like to, I think, prefer the already recorded presentation or the live presentation. So back to you, Dr. Ignacio. You please carry on your presentation.
Thank you very much. Then I assume our next speaker is Viraha Malayala, if I understood well, and the title is the data Mosul Dam data management. Is that right?
So I cannot see, I think, anybody from the, I think, AECOM right now in the presenter, I think, group. Yeah, so you please play the.
Yeah. Now we. So it must be a recorded video. It's live.
So I think.
Now the video is gone, for whatever reason.
So our fellow from the Icold, can you please upload the presentation?
Hello everyone, my name is Nagesh Malyala. I'm a technical leader with AECOM's Sacramento office in California. Been with AECOM for 12 years with an overall experience of around 21 years focused on dams and levees. Today my topic is Mosul Dam data management. I'm going to talk through the stuff. Firstly, I would like to thank my co-authors, Army Corps of Engineers, our clients, and Ministry of Water Resources with the Government of Iraq. So the Mosul Dam is the fourth largest dam in the Middle East. It is located 50 kilometers upstream of Mosul. The construction of the dam was completed in 1985. The purpose of the dam is flood control, irrigation, water supply, and hydropower generation. This is a cross-border watershed, which is almost abutting a couple of countries. The storage capacity is 11.1 billion cubic meters, or approximately 9 million acre feet. The length of the dam is 3.4 kilometers and it is 113 feet tall. The dam is an embankment dam and it has a grouting gallery at the bottom, which can be seen on the top picture with a circled as grouting gallery. The gallery basically runs through along the geological formation, which can be seen right here. It follows the geological terrain. So the locations of the dam are pretty steep. It varies from 0.5% to 41% in slopes at places. And since the dam goes through multiple formations, the configuration and the cross-section of the gallery is not the same across the board. It varies from circular to horseshoe shaped. Typically, it is around 3 meters wide and 3.7 meters tall. And in places, it is as narrow as 2 meters wide and 3.2 meters tall. So Corps did a risk study post ISIS stalling of operations, maintenance operations on this dam, and determined that an emergency grouting program needs to be taken up. So there's some key objectives were established. The objectives were to be accomplished in multiple phases. In the phase 1, a continuous single grout line across the dam was to be established. The grout holes were to be advanced to a depth of 50 meters below the gallery floor to stabilize the immediate foundation of the dam. And during this process, some open holes, which are just open, not because of the karstic formation, they are just open because they were not grouted properly during the previous time, were found, and that led to an extending the grout depth during the phase 1. And complete stage grouting of all the holes is part of the phase 1 objective. In the phase 2, establish a second grout line. So the first phase was to do a continuous grout line along the downstream alignment of the dam, of the gallery. And the second phase is to do the upstream alignment, and if possible, install a third line between the upstream and the downstream in the middle as the third line. And one of the objectives is to train and integrate the Ministry of Water Resource staff to be proficient with drilling and grouting program. So the operations were going on 24 hours and 6-day week. So in order to manage the data that is coming out, an agile data management, QA data management practices and procedures were needed. So initially, when the team was mobilized to the site on an ad hoc basis, we started with paper forms. The initial data collection was on paper, both by contractor and the engineer. The holes identification, grout stage information, mix type, drilling and grouting challenges, geology, equipment, everything was on paper. During this process, the T-Grout, which is the grout monitoring software, and AECOM was doing the QA data management application, were also being in development stages at the time. The need for the database is very important on a robust project like Mosul Dam. For the consistency of logging and uniform data interpretation, for quick and appropriate response, for reporting, for project management activities, and for contractor data validation. So in the consistency of logging, of course, if everyone logs the data consistently and interpretation can be made uniformly, then you understand the challenges and the geology a lot better. You can also understand the equipment limitations, which can help us in developing feasible solutions and also development of graphical displays. So the quick and appropriate response has to do with environments like Mosul Dam, where there is significant amount of karstification and significant artesian pressures that were encountered, which needed immediate solutions. So in order for that, the data collection and the need to assemble that data in a database is a key thing. For reporting purposes, daily, weekly, and monthly reports can be automated if the data is collected in a database. And for project management, to maximize the use of equipment, personnel, and proper utilization of resources, if everything is documented, then it makes it a lot more easy for the project management purposes. And finally, on a QA front, validating the contractor implementation of the work can only be done if the data is documented in a database properly. So for that purpose, AECOM built a data management application. It's built on Windows-based tablets. You can see the Panasonic ToughPad tablets right there. So the custom-built Microsoft Windows forms with SQLite backend database. There are 7 forms that were used. A couple of forms were to manage the grout characteristics. There are main batching plants to cover the 3.2 kilometers of the dam. 3 main batching plants were established on the site, and localized grouting plants were established at the grout headers or at the top of near the grout, near the collar of the grout holes. So a form was typically targeting the batching plant and a form for the header. And similarly, any samples that were taken from the grout that are tested in the lab were tracked on the lab forms. The grout volume, the production at the main mixing plant, and the consumption at the grout header were also tracked on a form. The drilling log, the drilling parameters were tracked on drilling log, and the grouting parameters were tracked on grouting log. You can see a typical grout log form here. The screen on the right side, on the left side, basically is the launching screen for a particular hole. It basically tells you the hole ID, the source main batching plant that is supplying the mix, the local batching unit that is pumping into the hole, what shift we are working on, whether it's an inclined hole or a vertical hole, what is the start date and date, and you know, what is the depth of the hole, what is the mix that was initiated with, and if it is, what type of stage, what type of grouting methodology was adopted on the hole. And the form on the right basically gives you a detail of each stage, how much quantity of a particular mix went into it, what is the methodology, any issues that were identified during the grouting is documented on the second screen. So a multiple stages of information basically flow into one particular entire whole, and that becomes one complete record. So the data synchronization, the entire Mosul Dam was equipped with fiber optic cables, and Wi-Fi hotspots were established across the dam. So the tablets were connected to Wi-Fi's, and the one-way secure synchronization was done from the field tablet to the local Mosul server, through which the data flows back to US servers, and where the data was processed and was published on the SharePoint site on the next business day, and was also made available through a web portal. So inbuilt QA system on the status of each form, or the QA of each form, is also tracked as a part of the application. So you can see on the bottom screen, on the bottom right-hand screen, it tells you the multiple steps. A form which has been closed in the field becomes ready for a QC, and something that is in progress is shown as progress. If someone picked up the tab of QCing that form, it is picked up in the QC, and if once complete, the status changes to complete and finalized. So this is how a data can be represented. As you can see on the left-hand side of the screen, there is a lot of, it's very busy graphic. You can see all those different symbols represent different challenges that were identified in the field. The arrows basically point out to communications, either grout communicating from one hole to the other hole, or drill water communicating from one hole to the other hole. The remaining dots are basically collapses, hole collapses, or water losses during drilling, or other types of issues. And the graphic onto the right basically shows you the green color is a grout take, a low grout take, and the red color is a high grout take. So it tells you like what geology took low grout and what geology took high grout. And the progress tracking certainly can be tracked using the data management application. A weekly completed borehole and the reasons why the production has dropped can be tracked if you are able to document everything in the database. Similarly, the drilling and grouting progress, as you can see on the top right-hand corner, can be tracked. If something dropped, you know that you may be in the challenging environment, or you may be there is a production downtime. Similarly, the number of rigs operating or the localized batching and grouting units operating can be tracked if it is inventoried properly in the database. Similarly, grout characteristics, whether the grout characteristics meeting the specifications or not, can be tracked if all the tests are documented on the quality control forms and inventoried in a database. The field reporting and operations planning, as you can see on the graphic in the lower left-hand corner, each drill rig is being tracked by the number of hours it has been working, number of hours it has been idle, and number of hours it has been down, maybe due to any equipment breakdown. And the position of the drill rigs, because this is a narrow gallery, and equipment cannot pass each other, so it is important to track them so that you can efficiently position them at the proper locations. And in the turnover to phase 2, one of the objectives was to train the local Iraqi personnel, and as a part of that, all the drilling and grouting material and the data management application has been converted into a guidance documents by marking up as shown on the screen, and the Iraqi personnel have been trained on how to use this for their own operations. So finally, conclusions. The choice of drilling and grouting methodology was based on the understanding of the geology and documented challenges. And tracking the usage of drill rigs, drill bits, core barrels, packer sizes, grout reels, packer pullers, and other specialized equipment was made possible because of the data management application. The choice of equipment and handling techniques were determined based on the challenges documented in the data management application. The choice of the grout mix based on documented field conditions and challenges was also made possible because of the notes that were put in the application itself. And real-time data collection certainly facilitated quick and easy decision making, and which resulted in smoothing out the process and improving the results. And planning and sequencing of the equipment was made possible only because of the data management application, because we were able to track every drill rig and every equipment. With that, I come to the end of my presentation. Thank you very much. I can take any questions if you have. Thank you.
Great. I'm wondering if you are connected, or it was just in the video that you were offering the. I think it's only in the recorded video, right, Pramod?
He's not connected. This is a recorded video.
It
Okay.
seems so.
So we skip to the next speaker, the 7th, right? Which is you again. So we will have time to questions and for the present. It is my pleasure to present my friend Jürgen Fleitz. I was thinking that I was reading the title of your presentation on dam safety, on smart management on dam safety documents, that maybe the audience needs to know that we've been working together for more than 20 years.
Yes.
And and I was remembering like around 2001 when we were implementing the, at that time, new safety regulation in Spain, and all those years that put us in a position as the position we are now, in which to share with us the leadership of your company. So thank you very much, and the floor is yours.
Thank you very much, Ignacio, Mr. Chairman. Good morning again to everybody. It's my pleasure to participate in this workshop. I will share the screen. Let me check. I suppose you can see the screen now.
Yes. Put it in presentation mode and. Perfect.
Yes, I think it's done. Okay, this presentation has been prepared together with my colleagues Oscar Perez and Stefan Hopper. All of us are working for the Spanish engineering company Optical, where we do now have an experience of 50 years in the field of dam safety management, and also monitoring and operation and maintenance of dams. And somehow the presentation summarizes some important aspects of these 50 years. You can see a brief contents of the presentation. The main purpose is to highlight the importance of a very well organized and systematic handling of all type of data and dam records that we are gathering over the large lifespan of a dam. I was happy to hear during the keynote speech from Mr. Pramod and Mr. Sharap that during the TRIP program, a big effort is made on this subject. For example, you are using a tool which is called DAMA, which is going in the same direction, trying to collect and organize all the important data regarding an infrastructure or our dam infrastructures. So what we try to evidence in this presentation is the importance of reliable data and to point out the present and future trends, taking into account the progressing digital tools we have in all fields of our life. So why is this so important? Why should dam owners focus on dam documentation and records? It definitely will help you to be more efficient assessing the dam behavior. It avoids the loss of knowledge over time. It helps to put in practice cost-effective operation and maintenance strategies, and it lays the cornerstone for the need for digitalization also in dam management. I'll give you an example what can happen if you don't have a complete documentation and data set. This may lead to a lack of information, and also it's a source of uncertainty, and even lead to incorrect diagnosis, especially during emergencies like floods. As an example, I show you this case of a 100-year-old gravity arch dam, which is located in the eastern part of Spain, close to the Mediterranean coast. In this area, it's very frequent to have high intense rain events that might originate flash floods, like the one you can see on this hydrograph. In red, you have the inflow to the reservoir. In blue, the outflow. This is an event that happened in October 2000. The 57-meter high dam with a crest length of a little over 300 meters was constructed in the 1920s, and severe floods caused overtopping, as you can see on this photograph, in several occasions, in 3 occasions, during the last century. Due to the insufficient spillway capacity that can be seen here on the left side of the photograph. The last time overtopping occurred was in the year 2000, precisely during the flood I mentioned in the previous slide. And all of a sudden, an uncontrolled outflow was detected here through the dam wall. And everybody involved with the management of this flood was trying to understand the origin of this outflow and to evaluate the possible consequences. And even dam break scenarios were considered, and the civil protection forces in the region were alerted. Finally, it wasn't after several days after the flood when the documents and drawings appeared that showed that a former pipe crossing the dam body had been sealed just in this area, but nobody was aware of that. So this lack of information during this emergency generated a very critical and stressful situation for the responsible dam personnel and also social alarm. So I think this example evidences the importance of a complete dam documentation file and the possibility to access the information in an easy and efficient way when you need it. Especially in case of dams that we learned during also the opening session of this symposium the other day, I stuck to the sentence that was said that dams are built for life, for history. So for a very long lifespan, over decades and even centuries, I think it's especially important to conserve and transfer, to conserve the data and transfer the knowledge from one generation to the next one. So a reliable data set is a key part in dam safety management. This is especially important in the world of aging dams we are in. As you know, it's a huge challenge to face this aging process, to keep our dams safe and functional. Many large dams worldwide have already reached the 50-year age, which is usually considered initially for the design of our dams. On the map, you can see in orange color the countries whose dams have a median age of over 50 years, and there's a lot of orange on this map, as you can see. In India, over 1,100 large dams will be around 50 years by the year 2025, which is not so long ahead. And over 4,000 large dams would pass 50 years of age at 2050. All this information, as well as the map, is included in a recent report, you may know, prepared by the United Nations University on Aging Water Infrastructures. So the big challenge, as I said, in the world is of this continuously aging dams is knowledge management. At that stage, I would like to remind the graph, which was prepared by Bernard Gogel and Darius Bonazzi. It was published already 30 years ago as a contribution to question 65 on aging dams in the Icold Congress in Vienna, but it's still very up to date. It shows in red, in the red line, the theoretical knowledge about the dam, which is cumulatively growing over time. In green, you have the living memory, referring to the data and information which is easily accessible and available at a certain moment of the lifespan of the dam, and which can be used to take decisions both for normal operation and emergencies. What we pretend to do with smart dam data management is to fill this gap we have between the living memory and the theoretical knowledge with technology, with connectivity, with transparency, and of course with well-trained people to take the best decisions to keep safe and functional our aging dams. Filling this gap is a matter of safety, of course, but it's also a matter of economy for a dam owner. So regarding this digital transformation, I guess all of you are using smartphones, so you are used to access instantly all different types of data and information for your personal and professional needs. We use new applications and features and can manage remotely the AC or heating systems of our homes. We can check our medical histories or financial operations, and we can, especially now during the COVID pandemic, work with our colleagues in collaborative environments across space and time, as we are doing now in this workshop. I think it's also high time to apply these possibilities to manage dam records and to switch from this situation to this digital one. Every engineer involved in preparing dam behavior reports or safety reviews probably has experienced how tedious and time-consuming it can be to search for documents, for reliable data, to validate the data, especially if there's no central archive or if there's gaps in the data sets. This takes a lot of time, and often more time must be invested for data collection and data validation than for the actual behavior and safety analysis itself. So I think it's the responsibility of the dam owner to collect, organize, and update all documents and records, and to allow to access and manage this information in an easy way. Digital transformation, let me see if I can play this video. Digital transformation is a process which is already present in many aspects of our life, and nobody doubts that it will keep advancing fast. Dams are no exemption, and some dam owners have already started to use powerful tools such as building information modeling, BIM, not only for the design and construction of new dams, but also for improving operation and maintenance tasks of existing dams. There are solutions that allow obtaining any information interactively, providing access to data and observations in real time. As an example, this online dam information system, ODIS, was developed by Optical a few years ago in the framework of a research and development program. The tool allows the use of 2D and 3D models, facilitating to schedule and design operation and maintenance activities, as well as inspection and monitoring tasks, and even to perform cost studies and budget follow-ups, as well as to link different processes of a project. So this online dam information system is a web platform which was prepared by different multidisciplinary specialists, and its main features are the easy access to information, the handling of inspection and maintenance sheets that are on the central database available to all users and can be even used on handheld devices during the field work. The observations that are made during the visual inspections, such as photographs, videos, numerical data, comments, sketches, etc., can be uploaded during the inspections and are instantly available. So this slide illustrates how visual inspections, field observations, and monitoring data can be processed efficiently, interactively, and in quasi-real time. The fact that all data records are stored in a centralized database avoids duplicities and uncertainties. We already started to use connected classes, which is a previous step to virtual and even augmented reality. The fields of application are really very wide. It starts with remote assistance by experts that can assist you from any place in the world. It leads to a better performance of our operation and maintenance activities. And as we are more efficient, we can also save costs. And it's especially important and useful to train personnel and to get them acquainted with our dam infrastructures. So as a conclusion, in my opinion, the digital transformation of our society will not stop and will also extend further in the field of dams. Dam designers should pilot and steer this process. There are many advantages, as I try to show in this presentation, helping to extend the safe and functional life of our dams. Let us push forward and lead as dam engineers this digital transformation before the IT industry takes over. And we, as dam engineers, just stay in the underpart. So I don't want to get me wrong. I don't want to displace the IT and financial managers, but it's still very important that dam engineers lead this process. But we should use, of course, these digital tools to support our good decision making. So let's go for DAMS 4.0 in this digital transformation. And I thank you for your attention and will be happy to answer any of the questions if you have.
Well, thank you very much, Jürgen, for this interesting presentation and up-to-date technology. The audience is not very active in the chat. Then I'm gonna throw you a question, and I'm gonna ask Pramod and Sarab to prepare their video that will be played after you. In this integration that you do in this smart management, how do you ensure that the knowledge is really well captured? Is the human review still a role in all this overwhelming information management? How we make sure that the knowledge and expertise still remains in place? Is it because of the personnel you have around the software? It is because you do some workshops on the issue? Is it because you envision a role for failure modes to be embedded there? So how are you going to make sure that the machine doesn't take over us?
That's a very good question. And that's what I wanted to say. Maybe I did not express myself too well at the end. As dam engineers, I'm a bit afraid that if we don't take the lead on that, it might be taken by other industries, by the IT industry that will come in, because digitalization is coming into all fields of our work. So I think we have to be ahead of it. We have to control it. We have to use these tools as a support, but not as an end in itself. So the process must be led by sufficiently well-trained people, starting from the engineers to the field personnel. That's what I also try to mention. we can use these tools to better train our people, which is also a big challenge to face the loss of information, the loss of knowledge, the loss of capacity. So the key issue is do it by well-trained people. I always, in different occasions, I insisted on the need to have trained people in dams, not trained people in IT systems. IT is a help, is a tool, but it has to be employed by specific trained technicians in dams.
I think now it's very clear, Jürgen. So thank you very much. To end the session, I'm going to give the floor back to Pramod, who wanted to share some more information. And if I understood well at the commentary that the RIP office has prepared. So Pramod, it is my pleasure to give the power back to you, and please proceed.
Thank you, Ignacio. Actually, let me tell, yesterday night I got this documentary prepared by our agency. So I'm just sharing with this limited group actually right now, just to go through it. Still it is to be approved by the, you can say, ministry and our government. So it's not official, but in this limited group, I'm sharing this documentary if possible. Let me play it. Just a minute. If it is working well, then very well. Okay. Is it audible, Ignacio?
Yes, I see
Hello.
it well. I see it well. No.
Me...
Okay, now it's starting. Good.
Okay.
But don't hear it.
Really? Just a
Yeah,
minute.
something with the sound. We see it, but we don't hear it.
Really? So I think voice is not going.
I wonder if you
Just a
play
minute.
it in your computer in a very loud mode, maybe we can hear it through your sharing screen system, I guess.
Yeah, just a minute, just 1 second. Yeah, you're correct actually. So just once, give me only 1 second. Is it audible now?
No, we don't hear it, at least not in my.
Not in my.
Now.
Little bit. Okay. अरे आवाज अरे I don't know. कहाँ जा है क्या है क्या नहीं आ रहा नहीं, अभी नहीं आ रहा yeah Ignacio, I think why now telling to you I think stop the I think
We could, I wonder if you are hearing me well. We could see the video, all the images, but at the end we could almost.
reach it
It was visual, very clear though, by the way.
you just give me अच्छा आपने बताई दिया इसको बोल दो लोगे ना तो you give me just 1 minute
Okay.
so
Ignacio, just give me 1 minute.
ठीक है
Now I hear you with a little bit of echo. Still, the images were very clear, and it was very nice to see, by the way. Now we hear.
आपो हिष्ठा मयो भुवस्था न ऊर्जे प्रधातन महे रणाथ चक्षसे, which means, O water, because of your presence, the atmosphere is so refreshing and imparts us with vigor and strength. You, who gladden us by your pure essence, we revere you. From time immemorial, water has been the elixir of life, the giver of life. World's greatest civilizations flourished along the banks of rivers and water bodies. India shares a deep spiritual relationship with water, which is why many rivers and water bodies are worshipped as goddesses. India has about 18% of world population, but has only 4% of utilizable water resources. So skewedness in demand and supply is reflected in various forms of water stressing. In ancient times, numerous traditional ways were prevailing to meet the local demands at a very small scale. Efficient water storage has been a part of city planning right from the times of ancient civilizations. 20th century marked the era of large dams. In today's world, dams are a vital part of our society's critical water infrastructure. Major components of comprehensive strategy to address major challenges posed by drought, flooding, depleted aquifers, environmental needs, clean water, clean energy, and food security, among others. In addition to direct benefits, these also provide numerous indirect benefits to a nation. As per International Commission on Large Dams, about 58,000 large dams are in operation worldwide. India ranks third with more than 5,300 existing large dams. These water bodies store annually approximately 300 billion cubic meter of water. About 4,000 Indian dams are more than 25 years old and 300 dams are more than 100 years old. The Kallanai Dam, which was commissioned in the 1st century AD, is providing services to the nation from more than 2,000 years. It shows that it is often misunderstood that the average life expectancy of a dam is mere 50 to 100 years. These engineering marvels have been constructed with huge investment. Long-term sustenance of these dams enables planned operational benefits from them. If a dam fails, it may cause loss of life, damage to property, and huge impact on environment. India experienced a few dam failures, the worst being the failure of Machu 2 Dam in the year 1979 in Gujarat. In current time, the major challenges being faced by our water infrastructure include climate change, making floods and droughts more frequent and intense. Aging risks with existing water infrastructure now require an infusion of investment and legislation to address safety and reliability. A fundamental disconnect in current time is society has been quick to privatize development gains and socialize development risks around dams. Provision.
India's DRIP is the largest and the most important project, and which have been providing a lot of support for rehabilitating and ensuring safety of many existing dams. The DRIP now has been showing the important model for how to enhance this dam safety framework to the other part of the world.
Preparatory activities took about 3 to 4 years initially, which include establishment of state project management units, inspection of 260 dams by agency-specific dam safety review panels with appropriate recommendations, design flood review of 250 dams, preparation of project screening templates for 250 dams, including approval by CWC and World Bank. The scheme has 3 components. The first component deals with rehabilitation of selected dams and its associated appurtenances. This component has almost 84% of project cost.
Dam rehabilitation and improvement project is dedicated to improve our existing water assets, thus will provide long-term water security to this country. This scheme will make resilient dams, resilient communities, and will address new challenges of climate changes also, which may result in possibilities of extreme floods or drought in near future.
One of key achievements of DRIP has been that 158 dams now have improved ability to safely pass the revised design flood. The various measures undertaken to improve the ability of these dams to trade off the increase in design floods include construction of parapet walls, additional spillways and modification of existing spillways, flush bars, fuse plugs, repair of spillways glacis, and downstream energy dissipation arrangements.
In the DRIP program, we have taken the pointing, reaming of the pore holes, the restoration of the baffle wall in the stealing basin, and for the safety and security purpose, we have installed 3 cameras and HIMARS lights, and security rooms also constructed. This DRIP scheme has helped to address dam safety issue to a large extent.
The operational safety of a dam is guided by man-made activities like operation of spillway gates, sluice gates, hoisting system by manual or through automatic control system with human interface. The 128 dams have been strengthened in this area, which include repair and replacement of spillway gates, under sluice gates, hoisting system, control system, and SCADA. The excessive seepage through a dam beyond a permissible limit may lead to water loss and undermine the safety of a given dam if not attended in time. About 69 dams have been attended with various seepage reduction measures, which include application of geomembrane, grouting, improvement in foundation and cutoff, raking and pointing of upstream faces, joint treatment using hydrophilic materials.
Some facts on the DRIP project where I have been involved for more than 2 years, and one is the exceptional work on capacity building, the appropriate way in which the risk framework has been adopted, plus an enormous and very remarkable work on diagnosis and rehabilitation projects. All these together with reinforcing new legislations and best practices from all senses. And India is becoming a mirror for the world, as you are not only adapting, but making a good progress on best practices on dam safety.
The structural safety ensures that a given dam is safe in case subjected to extreme loading conditions. Under DRIP, 153 dams have been improved in this respect through various measures like rehabilitation of dam abutments, improvement of slopes and drainage, earth dams resectioning, reaming of porous and foundation drains, strengthening dam section by providing backing concrete. Apart from major rehabilitation activities, the improvement of basic facilities is equally important from disaster management perspective to ensure quick response during any emergency. These facilities have been improved for 165 dams. These include improvement of dam access roads, culverts and bridges, external and internal lighting, standby generators, material testing facilities, control rooms, repair and improvement of dam safety offices, staff quarters and inspection houses, security arrangement, and training facilities. Instrumentation and dam health monitoring is considered the backbone of comprehensive safety evaluation and health monitoring of dams. This helps in planning of suitable rehabilitation measures at appropriate time and prioritize the allocation of limited financial resources. This information is vital for risk-based decision system in dam safety. Instrumentation and monitoring systems have been proposed for 115 dams. It has been ensured 5 years post-installation warranty that installed instruments must work for minimum 5 years.
It's not just about safety in its narrow sense. It's really about saying that how do you invest in breaking an important cycle which we see all over the world. And the cycle is build, decay, and rebuild. Can we break this paradigm and ensure that build is followed by intensive operations and management and support of how to turn an infrastructure asset to produce the services for its citizens? We have to invest in the ability to build and manage. That's the commitment that we have in DRIP.
Non-structural measures are equally important in mitigating associated risks with the dam. Two most important documents include Preparation of Emergency Action Plan, Operation and Maintenance Manual. These two documents contain adequate operational and emergency flexibility to efficiently handle any emergency and smartly operate the reservoir over a period of time. Central Water Commission has completed dam break analysis and inundation mappings for 222 dams and provided to all partner agencies. Under DRIP, each dam has been equipped with these two important protocols.
With the introduction of Dam Rehabilitation and Improvement Program, the World Bank supported program, this has changed the way we are looking at dam safety in the state. Through this DRIP program now, there is a continuous training and capacity development of the engineers associated with dams.
Another important beginning includes dissemination and implementation of published emergency action plans through stakeholder consultation programs by inviting all stakeholders. This initiative of public consultations had been appreciated by all disaster management agencies at state and central levels, which is altogether a new beginning through this scheme.
Without gas, we cannot survive. So, studies like these and the efforts being made, because unless we all come together, work together, strive together, we will continue to make rainfalls as floods. And if we all work together, analyze the things, prepare ourselves well, then definitely we will be avoiding many disasters in future.
Second component of DRIP is focused on dam safety institutional strengthening, which is one of the most important pillars of dam safety. This includes customized national and international training programs. About 179 national programs have been conducted, wherein about 5,200 officials have been trained, in addition to 5 international training programs. Capacity building of 8 academic institutions. Also, capacity building of 2 central institutions, CSMRS and CWPRS, had also been done. All these institutions have been strengthened through latest laboratory instruments, equipment, advanced modeling software, as well as exposure to field problems.
We are very grateful to the DRIP project that we were able to develop several of our laboratories and other technical support like software, etc., with the help of DRIP projects in almost all the major departments of the institute.
This is the foundation for creating a pool of trained dam safety professionals to handle various challenges in coming time. To meet the long-term need of trained professionals in the country, a postgraduate MTech course in dam engineering has been started by IIT Roorkee, IISc Bengaluru, and IIT Madras. The standardization and publication of technical guidelines and manuals is an overarching pillar in dam safety. Under DRIP, 14 guidelines and manuals have been published. These documents will assist Indian dam owners to initiate advance action for various important activities envisaged in proposed dam safety bill. To ensure global acceptability, leading national and international experts were associated. Annual Dam Safety Conference has been a regular activity since the year 2015 onward. These conferences provided a common platform to DRIP as well as non-DRIP states and other dam safety professionals to share their knowledge and experience. During these events, in addition to knowledge sharing, DRIP has also attempted to showcase our local culture and traditions of concerned states through cultural programs to make participants familiar with rich Indian culture and traditions. During DRIP implementation, official collaborations with various leading global institutions like Deltares, Netherlands, United States Bureau of Reclamation, Japan Water Agency, Entura, Australia, Polytechnic College, Valencia, and Spancold, Spain, to address long-term sustainable management of existing water infrastructure, a web-based tool called Dam Health and Rehabilitation Monitoring Application, or DHARMA, has been developed to manage dam assets systematically.
Project like DRIP is not so much important from the point of view of physical rehabilitation of dams, but the other benefits of these kind of schemes are brings in. The mention was made of all kinds of guidelines, all kinds of manuals which has been created, all kinds of software like DHARMA to know the health of a dam which has been created, the emergency action plans which are being prepared.
Construction supervision and quality assurance are supposed to be the backbone of any infrastructure project. The third-party construction supervision and quality assurance was entrusted to Central Water Commission. Through CPMU consultant, CWC conducted more than 1,000 CS and QA visits, including more than 600 construction material samplings during scheme implementation. The appropriate corrective actions were suggested to all partners. The third component is project management. Monitoring mechanism was very robust. The National Level Steering Committee, headed by Secretary, Department of WR, RD and GR, and concerned state principal secretaries are its official members. This committee focused mainly about policy-related matters. The Technical Committee, headed by Member, Design and Research, Central Water Commission, with appropriate representation from partner agencies, dealt with technical matters related to this scheme. Third one is World Bank Implementation and Support Review Mission, to review the scheme independently and evaluate the performance rating. This mechanism has steered the scheme very successfully to achieve the intended objectives. In order to manage flow of huge information systematically, a management information system was put in place right from the beginning with weekly update. This MIS is a resource bank for all the partner agencies to monitor the scheme systematically and retrieve any information. In addition, various overarching pillars of any system, legislation is considered one of the most important. Current government has given much needed importance to this pillar.
India has been embarking in a very strong program in terms of rehabilitating the dams in order to ensure safety. It would be very good for the country if the Dam Safety Bill would be enacted very quickly.
Dam Safety Bill 2019 has been passed by Lok Sabha in August 2019. The proposed legislation is very comprehensive and have adequate provisions to ensure health and mitigate risks associated with dams.
बांध सुरक्षा के लिए अवेयरनेस क्रिएट करना और साथ-साथ में जो बांध के ओनर्स हैं उनमें सेंस ऑफ रिस्पांसिबिलिटी और सेंस ऑफ क्रिएशन ऑफ अवेयरनेस इन दोनों के लिए आवश्यक है कि इस विधेयक को पारित किया जाए
The foundation for effective dam safety assurance in India is available with the proposed dam safety legislation that captures the legal, institutional, technical, and financial elements. This legislation will ensure sound construction, safe operation, and sustained services from existing water infrastructure and will safeguard the downstream communities while enabling economic development. The enabling legal framework for dam safety assurance will serve to establish the minimum standards, along with duties, roles, and responsibilities for assuring the safe development and operation of dams. Based on the success of DRIP Phase 1, the Union Cabinet approved a new scheme, DRIP Phase 2 and Phase 3. This new scheme has 19 states and 2 central agencies on board with pan-India participation by dam owners.
Dam Rehabilitation and Improvement Program Phase 2 and 3 दूसरे और तीसरे चरण की मंजूरी दी गई है। 10 साल की यह परियोजना 2 चरण में होगी, जिसकी अनुमानित लागत 10,211 करोड़ रुपए होगी।
DRIP is going to prove a great rescuer for our Indian dam owners in many respects, especially in enhancing the institutional strengthening of various partners. Ministry of Jal Shakti and Central Water Commission acknowledge the valuable support provided by all official partners and other stakeholders of scheme and would like to take pleasure and pride in working together during the next scheme for better dams for better tomorrow of India. Jai Hind, Jai Bharat.
Back to you, Dr. Ignacio.
Mr. Pramod, Ignacio just sent me a message. He had problems with his his internet connection. He tries to get in. He tries to get in. Maybe he can manage it.
So I think we can close the session. So shall we wait for Dr. Ignacio?
He just told me he's trying to get in. Let's maybe wait a few seconds, and if not, you may close the session. He told me to ask you to close the session if not.
Okay. So let me wait for a few seconds actually.
Okay.
In case he is back. So there was a time lag of 30 seconds actually. I was just seeing through my desktop also. So it's I think may not be enjoyable video to all of you. Jagan, how was the video?
It was great. Congratulations. It was a very, very comprehensive and very nice video explaining by detail all the achievements you made during trip 1 and also looking forward to trip 2 and 3. So
Yeah.
very impressive. Congratulations to this big job. Great job you have done.
Thank you, Jagan. So Dr. Saab, we are waiting for the Dr. Ignacio.
I will ask him if he wants us to wait.
Yeah, please ask him to join. He can close the session.
Let's see. I just sent another message to him.
Dr. Ignacio was playing with the system, I think. And some connectivity issue.
No, he's not answering. He saw my message, but he's not answering yet.
He is trying, I think.
He must be trying to get in.
Yeah.
I see it. He came back.
Good.
back somehow.
Yeah, great to see you, man.
There must be a with the Wi-Fi in neighborhood because after 8, exactly after 8 o'clock.
Yeah, you have connection problems.
Working well, right?
Yeah, some internet speed, I think, issue.
So I'm gonna thank you all very shortly and leave Pramod to close the session before I have more technological problems. But it's been a great lesson.
So yeah, I think there's some problem again with the, I think, connectivity of Dr. Ignacio. Again, disconnected man, I think. My dear fellow, disconnected. Yeah, I can see the
He has problems.
Yeah, some connectivity issue. Yeah, man. So I think I can close the
I'm
session.
connected, but here without delay. So
Okay. So we can close this session. I think this has been a very informative session for all of us. 7 presenters, I think, with a variety of, I think, information. And some of the presentations were very useful in context of the dam rehabilitation. So on behalf of Chair, Dr. Ignacio, I extend a big thanks to all the presenters of this session. At the same time, the audience and attendees who are attending this session. And big, I think we are very grateful to the Encode and the Icold also, who have given us this opportunity to conduct this session. So thank you all, and I wish a very, I think, safe and big time ahead for all of you. Thank you very much. Thank you again. Thank you.
Thank you, Mr. Pramod. Thank you, Mr. Chairman.
Encode fellow, and thank you very much. Have a nice time. Good day.
Stay safe.
Too.
Goodbye. Goodbye. Thank you.
Bye-bye.
Thank you. Bye-bye.
Bye-bye.
we'll see you in, hopefully. See you in person soon, hopefully.